as much in law, and we should. Because that distributed verification, that invention, that scientific breakthrough, which allows us to make decisions which are provably, which we can prove have integrity, which we can prove are the correct or incorrect answers, even though they're held by thousands, millions, even billions of different nodes on a network. That enables an entire set of possibilities which we didn't have an answer for in computer science 20 years ago when I was in school. Now, blockchain 1.0 was just about digital objects, cryptocurrencies. That's wonderful. But if all you can do is just exchange tokens, that's not an economic system. You have to be able to tie that to something. What if I want to exchange a token only when something else happens? Like a basic contract. And that brings us to blockchain 2.0. Many of the people involved in the Bitcoin project early on wanted to be able to make the Bitcoin network work such that you could say, I will only transfer this Bitcoin to you if something else happens, or when something else happens. And for a variety of reasons, which we don't have time to get into, the Bitcoin network did not implement that very well, if at all. And so some of these people split off and started developing other technologies. Technologies that were capable not only of performing distributed verification for the maintenance of ownership, the right to a token or a part of a token, but also to be able to program into that same consensus, that same distributed verification, the ability to say, we will execute this transaction if and when something else happens. And this gave us Ethereum, and then later, for certain technological reasons, EOS. And these technologies, which are considered some of the leading technologies in blockchain today, allow us to have the types of what we call smart contracts, executable agreements where you can program into the system the ability to transfer ownership, to transfer assets, to pay for something under certain circumstances. This led people to think, well, wait a minute, if we can program things, if we can instruct the computer to do transactions, for example, like running operations in logistics, or in manufacturing, or in sales, again, as my colleague talked about in the first keynote. Maybe we can actually start to write full-blown applications. We can write what we call DApps, distributed applications. But we had a problem with Ethereum. And some of you in this room may have heard of the crypto kittens example, but there's a joke in computer science that the Ethereum network runs scared at the sight of a baby cat. And the joke in computer science and the blockchain community comes from the fact that there was a DApp written, which did not do a whole lot more than allow people to trade, maintain kittens. It was a cute little application that someone wrote. And in December of 2017, it nearly crashed the Ethereum network. Ethereum was not designed to be a platform for building apps. Ethereum was designed to be a platform for contracts. So even though it technically is what we call in computer science Turing complete, that means it's capable of arbitrary computation for the to put it in simple lay terms, you can build any program, any app you want on a Turing complete system. But Ethereum didn't really work that way because it did not scale. It did not work at global scale for any app. It worked at global scale for any app if that app was really an agreement. And so the EOS project, which is a very, very large project, an offshoot of Ethereum to some extent, is now trying to build that type of global platform. You might call this blockchain 2.5. It wants to build an environment for true distributed computation. And that brings us to what I call blockchain 3.0. Now, I imagine many people in here have heard of the term the cloud, or cloud computing. And for about 15 to 20 years after that term first came about, any chance I would get, any opportunity, I would say, this is a terrible term. There is no cloud. And that's actually true today and for the past 20 years. Because the cloud, when we say it like that, implies that there is something out in the world, some entity, some structure that we can access. And that's not true. Rather, there are a series of companies like Amazon, Google. I think Huawei does something with this, but I'm not entirely sure. And others around the world, which maintain their own clouds. So when you access the cloud on Amazon, you're not really accessing some global entity that many people have shared operational control over. You're accessing Amazon's cloud. What EOS gives us, and what a true, full, third-generation blockchain will give us, is the ability to have a cloud. A true cloud that we can call the cloud. A distributed system out in the world, arbitrary computation, a term in computer science we call object agnosticism. It's a fancy sounding term. All it really means is that it can hold any type of data within the container. So instead of a blockchain that only handles bitcoins, it would be a blockchain that could handle any type of digital object. This can enable the full spectrum of digital ownership concepts. Consensus algorithms can now be used to answer arbitrary questions, not just questions about who owns one token, not just questions about has a contract condition been satisfied, but any question that you want to ask of this large entity. And as I mentioned before, we can start to think about more advanced data structures to improve performance, efficiency, and enable other types of things that are beyond the current capabilities of projects like Ethereum. Let's talk a little bit about how this might work out in practical use cases. The most common example is multimedia. The internet brought with it the ability to distribute digital objects at nearly zero marginal cost, as an economist would say. That means that when I have a song on my phone and I want to share that song with someone else on their phone, it costs virtually nothing to make that copy. This massively disrupted the economic systems that had been in place for essentially centuries, hundreds of years, and created many questions in law that are still being hotly debated today. And one of the core reasons is we had no ability to be able to say who owned one copy and to prevent someone else from also owning that copy. Blockchain 3.0 implementations can allow for this. Another example is logistics. I'm not going to say very much about that because our wonderful first keynote speaker gave us a wonderful long explanation on it. I do want to note also health records. As medicine has advanced, the complexity of the information